Welcome to Train Signal. You're watching the Lab 4 video on DHCP in Windows Server 2003. In this video, we're going to take a look at how to install a DHCP relay agent and also the benefits of that, why we might want to use that configuration. We're also going to take a look at some DHCP properties. Okay, but we're going to start off by doing this DHCP relay agent overview. Then we'll go into lab setup, how to set up the scopes. Then we'll talk specifically about the installation and configuration of the DHCP relay agent, test this out, and then we're going to focus on some server properties, things you can configure, check out, troubleshoot, and backing up DHCP. Let's get started by taking a look at an overview of this network. Okay, and we've changed things up here slightly again. We've modified this lab environment so it fits what we're trying to accomplish in this particular lab. Now this machine here, the XP machine, is identical to what we've seen previously. Okay, so we have XP1, it's just going to be a DHCP client. However, currently it does have an IP address. All the machines on this network right now have a static IP address. And the reason we have that is so we can set up some general testing and configuration up front, but we will change that. Server 1 doesn't play a large part in this lab. It's sitting here, it's acting as a domain controller and DNS server as it has throughout this lab. You can see that it has the same IP address, 192.168.1.100, and the default gateway it has is pointing over here, okay, to 192.168.1.230, okay, which brings us to our first change, and that's in server 3. What we're going to do with server 3 in this lab is set it up as a multi-homed server. Okay, what that means is a server with basically two network cards. Okay, we've got a network card here and a network card over here. Okay, and you can see the IP addresses that are associated with each of these network cards. 192.168.1.230 is the IP address we have configured on this side, and 192.168.2.230 is the IP address we're using on this side. Okay, and that also corresponds with the different network IDs that we have set up. On the right-hand side over here, this is going to be the 192.168.2 network ID, and you can see that up here as well. On the left-hand side, we're using that same network ID that we've used throughout, and that's 192.168.1. Now, what's going to happen on server 3 as well? We're going to enable our RAS. This is going to be a router, so it's going to be capable of passing traffic back and forth between our two different physical segments. And eventually, we're also going to put a DHCP relay agent on this computer. Okay, and we're going to talk about what that means here in a second. On the right-hand side, server 2 is going to be acting as the DHCP server as always. Same, actually different IP address, 192.168.2.200, with the default gateway of 192.168.2.230. Now, if you look at this default gateway, you see that it does point to this IP address, and this is a very crucial concept that you understand when it comes to default gateways. A default gateway of a computer will always point to the local IP address of the machine it's trying to connect through. So for example here, this machine has two different IP addresses. Well, server 1 is going to have to connect through here on this side. This will not be the default gateway of any computer on the 192.168.1 network. Okay, let's clean this drawing up a little bit and talk more about what the actual DHCP relay agent is used for. Okay, here we're in a situation where we have a multi-segmented network. We have two different segments, yet we only have one DHCP server over here. Okay, and if you know anything about DHCP so far, from going through this, you realize that DHCP clients actually broadcast out. Okay, so they boot up and they're broadcasting out looking for IP addressing information. Now, when they broadcast out, this router or any router, by default, is going to block that broadcast. Okay, so this machine is going to be attempting to pick up an IP address, but what you'll see is that it won't get through to server 2 in this case, and it just won't get an IP address at all. Okay, well, in actuality, it's going to get one of those private IP addresses, 169.254, that we talked about in Lab 2. So what to do here? Well, we have a couple different choices. Depending upon what type of router you have sitting here, okay, you may have something that has a standard called RFC 1542. I'm going to put the number down here below. Okay, and this is supposed to be a 5. Okay, RFC 1542. If you have an RFC 1542 compliant router, what that means is it's capable of passing boot P or DHCP traffic. So what it'll do, normally it blocks all broadcasts on the network. So if somebody else is broadcasting for some other reason, that broadcast will be stopped. But if a DHCP broadcast is picked up, they realize that this machine is just trying to pick up an IP address, and this broadcast here is going to be allowed to pass through the DHCP server, okay, up to the DHCP server, and then back again. This computer is going to actually speak with a one-on-one direct unicast message. Okay, so RFC 1542 will allow this. If you do not have an RFC 1542 compliant router, or if you're using, in our case like we have here, Server 2003 as your router, what you can do instead is create what's called a DHCP relay agent. Okay, and a DHCP relay agent is set up, and the goal of the relay agent is to listen for DHCP traffic on this segment over here, and then pass that information over here to the actual DHCP server. So the goal is really almost identical to what the RFC 1542 compliant machine is. Okay, so to do this, however, a couple things we have to keep in mind. Number one, we have to have RAS enabled, so we're going to have that here. Secondly, we're going to be using a DHCP relay agent. Thirdly, we need to enable this relay agent on the network interface where the DHCP broadcasts are going to be caught. Okay, and in that case, it's going to be on this side of the network. This is where we're going to have DHCP broadcast. Okay, and that makes sense. If we had an XP client over here and it were broadcasting out on the network, what's going to happen? Well, it's going to broadcast out, and server 2 is going to hear the broadcast. There's no reason that it's going to have to pass through the relay agent to get to server 2. Okay, broadcast on this side will be stopped by the router. Okay, so what it will do is set up the relay agent to listen for those broadcasts. Anytime it does pick up DHCP broadcast, it's going to be configured to point directly to this DHCP server, which will then dole out the IP address and IP address information to XP1. Okay, so that's basically the premise of what's going on here. Now what we're going to have to do is just set this up a little bit. Okay, and some things we're going to need to do. Well, we're going to have to go over here to server 3. This has to be configured. Relay agent has to be configured. A little bit of scope cleanup over here on server 2. Okay, and XP1, I believe, and server 1 are for the most part okay. The one thing, as I mentioned before, all of these computers right now have static IP addresses, so we're able to communicate and connect through. So first things first, we're going to connect over to server 3. We're going to have to enable routing, because at this point right now, we can't even get from XP1 to server 2 because there's a machine here that's blocking us, and right now routing is not turned on. Okay, so that's what we're going to do first. We're going to form a remote desktop connection from XP1 over to server 3. Okay, we have to specify the proper password here. Okay, now we're sitting on server 3. And server 3 is already has the DHCP service uninstalled, so we don't have to worry about that. What we will take a look at, however, are the network cards on server 3. If we come here and look, we have 2 different network cards now, and during our off session between Lab 3 and Lab 4, I have enabled this and reconfigured the physical network just as you see down here. Okay, and that's something, before we get too far ahead of ourselves, let's talk about exactly how we have this configured. Okay, well, if we're talking about strictly just a physical network, it's pretty much the same as you see here, but just so you're clear, there is a hub over here, okay, and a hub over here. These machines are plugged in as so, and then this machine's second network card is plugged in here as well. Okay, so this is what we're dealing with here. Server 3 is the machine that we just went to, and we're going to go back to in a second here, and we're going to be configuring the IP addressing information right here. It's actually already set up, but we'll take a look at it and see how we need to configure this. Okay, so let's go back over to server 3 now. So here are the 2 different network cards on server 3, and what we'll do is we'll take a look at the IP settings on each one of these cards. Okay, the IP setting on the network card on the left-hand side on the 192.168.1 network is at 230. You see the subnet mask is 255.255.255.0. The default gateway is not set. Okay, and in this case, you typically do not want to set the default gateway. We're not setting up an internet in this particular case, so we'll leave this alone. The DNS setting will not be important for this particular lab, but it's something that in most cases you want to make sure that's configured. So we'll go ahead and configure it. And that's pointing out to 192.168.1.100 server 1, which is running DNS. Now another thing I'd like to do, I don't know how we ended up with 3 network cards here. I think this is just a screen resolution glitch. Another thing I'd like to do is rename this network card here so it's not just local area connection, but it's actually renamed with the network ID that it belongs to. So now it's going to be real simple if I come in here to tell which network card this particular card is plugged into, or which network this card is plugged into. Okay, now over on local area connection 2, the default name, we see that we have 192.168.2.230 configured. Same subnet mask, default gateway doesn't need to be configured. DNS we can go ahead and set identically to the other network card, 1.100. And we'll click OK here, and we're going to rename this network card as well to 192.168.2.0. Okay, so now it's real simple to identify which network card belongs to which different network. Alright, so we're set up here with our TCP/IP settings. Now let's go into routing and remote access, and we're going to enable this on this particular machine. Okay, here's routing and remote access. And if you're not familiar with RS, we do cover this in great depth in Labs 7, 8, and 9, and there's all sorts of things you can do with RS. It tells us right here. We can set up a VPN, we can set up a remote access VPN, a basic firewall, routing, which is what we're going to do, a NAT server, which will connect you out to the internet, a dial-up remote access server. So all sorts of things can be configured within routing and remote access. So for us, we're just going to go through here and select configure and enable routing and remote access, and then go through this wizard. We're going to specify a custom configuration, and we're choosing this bottom option here, local area network routing. Click next, click finish, and it's all that we need to do to get routing set up and enabled on this particular computer. Okay, and what we should be able to do now that we couldn't do before is ping from one side to the other. Okay, if you look, before we just enabled routing, we could not get from here through over to here. Okay, that wasn't going to happen. We'd be able to ping all the way up to this point, but when we tried pinging this network card, we just wouldn't be able to. Our computers weren't configured correctly to be able to access that. Now what we can do, though, since we have routing set up, we can actually get through, we can have our ping and all other traffic, for that matter, redirected over here to this side of the network, and we can communicate back and forth between these two different computers. Okay, let's take a look at that and let's see if we can actually do that. So from XP1, let's see if we can ping over to 192.168.2.200. So we're going to go to a command prompt. Okay, 2.200. Okay, and we can't. Okay, for some reason it's not set up or it's not working right. So good time to troubleshoot. So from our end, let's first take a look at our local IP settings here on XP1. That's a good place to start. So when we look here, we see that this computer is 192.168.1.1. Okay, that looks good. Default gateway is pointing out to our default gateway, so that should be okay. 192.168.1.230. Okay, so happy with that. Let's go ahead and try and ping our default gateway. Okay, and you can see there that that is successful. Next, let's go one step further. We reached this location here. Let's try this location here, which is 192.168.2.230. So I just did a up arrow, make this a little bit simpler, and you can see this is working as well. So we have no problem reaching this location. Okay, so that leaves us with, now we have to get over here to server 2. And server 2 is configured with 192.168.2.200. Okay, so let's see if we can't make that work. Okay, and for some reason this just isn't working. So what that tells me is that most likely there's an IP configuration error over on server 2, and it very easily could be the default gateway is not configured. Okay, now unfortunately we're not going to be able to form a remote desktop connection over to server 2. Okay, we'll go ahead and try it just to show. Okay, because we couldn't ping over there, so it's not very likely that we're going to be able to do something that's even at a higher layer than, pinging. So what I'm going to do is stop this video momentarily. I'm going to fix the problem and then let you know what it was, just so there's no confusion as to what the deal was. So we'll stop this video and start it right back up again. Okay, it was the default gateway setting over here on server 2, so this was pointing to the old default gateway that we had, 192.168.1.254, which just is not going to do the trick when it comes time to reroute that TCP/IP packet back here through our router. Okay, so that has been corrected, and we can double check this right now. We're going to ping from XP1. Okay, 192.168.2.200 is the IP address of server 2 over on that other network ID. And you can see here that we are able to ping it. We get a reply back from it. Okay, so that's a good sign. Now, if we were going to just set up XP1 as a DHCP client right now, what would happen to it? Okay, just out of curiosity before we connect over to it. Well, let's go ahead and try that out and see. Okay, so we're going to go here to Start, Command Prompt. Actually, let's go up here to our network connection settings since it's not already a DHCP client. So right-click My Network Places, we go to Properties, and we'll go into TCP/IP, Properties, and we're going to obtain an IP address automatically. Okay, so I click OK here, and it'll take a couple seconds, but what we're going to find is it's not going to be able to find a IP address. So when we go out here and type IP config, you see that right now it didn't pick up anything as far as an IP address is concerned. Type it again and we still have nothing. So in this case, for some reason, it didn't even pick up that classless, that APIPA, automatic private IP addressing address like it normally would. Okay, so let me try that again. IP config still has got nothing. I'm going to try an IP config renew. Just out of curiosity, I'm wondering why it's not picking up that automatic private IP addressing. Not that it would do us any good anyway, but we'll see here in a second that it should pick up that 169.254.random.random number. Okay, so it's not able to basically broadcast out, go through the router, contact the DHCP server, and then have an IP address come back. Okay, the broadcast is being stopped right here, and that's what we're looking to alleviate using this DHCP relay agent. Okay, so that's what we're going to set up here. So coming back over to the command prompt, we still don't have any response here, so we're not getting what we're looking for. We're not finding that DHCP server. Okay, so what we're going to do, as soon as this times out and we find out that we can't get that, we're going to statically set this machine back up again, okay, give it an IP address, then we're going to connect back over here to server 2. Once we're on server 2, we'll take a look at a couple settings before we come back over here to server 3 and finish out our DHCP relay agent. Okay, still looking for an IP address over here, and we're still not broadcasting out and finding one. Okay, finally we get an error. When we type in IP config, we see that we do get that automatic private IP address 169.254, in this case 195.35. Okay, that's not going to do us any good, so we're going to change this. Okay, and the reason I'm changing this right now, by the way, is because without changing this IP address, there's no way for us to get through here and configure this. Okay, I want to show you what we're doing on both of these systems. Okay, and the way we have it configured right now, this machine's on an island here. Okay, so we're going to set this back to what it was before. Okay, I think that'll work. 192.168.1.1. Subnet mask is good. Default gateway is very important. That's pointing out to, I think that's actually incorrect. We want to point it to server 3, which is at 230. Okay, let's check our diagram just to make sure. Server 3, 192.168.1.230 right here. Okay, so that's why we have this configuration. DNS won't matter, but that is pointing to server 1. Okay, so once we get this configuration accepted, then we can use that remote desktop connection as I mentioned, and we're going to connect right back over to server 2, our DHCP server. Okay, so we're logged on over here on server 2. And I think what we're going to do here is just kind of take a peek around at the DHCP console, take a look at how it exists right now. So we're going to clean this up a little bit. Another thing we're going to do, I don't think it's going to have a bearing, but routing and remote access, I believe, is turned on this system. Yes, it is. We don't need that anymore. We used that in the last lab. We're just going to go ahead and disable this. So if you're following along, you're actually setting this up on your own, you want to disable this as well. I don't think it's going to have any detrimental effect that I can think of off the top of my head, but nonetheless, we're not using it. Let's get rid of it. Okay, so I'm disabling this. Another thing I did kind of behind closed doors, so to speak, when you weren't watching, is I changed some IP address settings that we had configured previously. So let's go take a look at what we have now. Just one network card's enabled. And on this network card, we're using the IP address 192.168.2.200, and that matches our diagram, so that's no surprise. The default gateway is pointing back to 2.230. That's the router's near side IP address. So all this information is exactly as specified on the diagram. The one thing we did change, though, in Lab 3 we had used an extra IP address. Okay, 2.200 was actually the extra one at that time. Well, what you want to do is get rid of that 1.100 or 1.200 IP address that you had previously set here. Okay, so at this point right now, there should be just one IP address, and that's 192.168.2.200. Okay, and then once we have this set up like we do now, we really have everything in place. Okay, the last thing we'll do here, though, we're going to take a look at our DHCP console. Okay, currently right now we have unauthorized this, so it's not part of the Active Directory domain. So if we wanted to authorize this once again, we could re-enable this, or we don't necessarily have to make it part of the domain Active Directory either. Okay, what we're going to do in this case, we'll go ahead and authorize it. So let's just right-click, go down here to, up top, right-click, Manage Authorized Servers. We're going to authorize, and I'm going to type in the IP address of this system. 2.200. Click OK. Click OK again. Okay, and we're having a problem contacting Active Directory, and let's trace it back to DNS. Let's make sure that DNS is not an issue here. So if we take a look, let's one more time gander at our settings. I think we had them correct, but 192.168.1.100, that is the DNS server. We should be able to reach it now too. Let's go ahead and try pinging the DNS server and see if that works from here. Yep, no problem with that. Okay, so showing up as not authorized. Let's try this one more time, see if we get something different. Okay, manage authorized servers. Authorize, let's type in server2.wbc.local. Okay, following DHCP server will be authorized. Enter any necessary corrections below and click OK. Okay, and for some reason the DHCP service is not able to contact Active Directory. Okay, what we're doing, we're running into the same problem we had when we were in the first lab. Okay, we're logged onto this machine, it looks like, without being logged on to Active Directory, so the credentials aren't matching up. So, demonstrate this, what we'll do, let's go ahead and close this connection. We'll actually log off this connection. Okay, so we're logging off of server 2, and I'll tell you what I'm talking about when we go right back here and connect over again. So now we're back on the XP machine, and we're just going to form that remote desktop connection back over to server 2 again. Okay, 2.200. Okay, right here we're logging on locally. Okay, and this is an important point to point out. You may run into the situation when you come to a server. If you're logged on locally, well, your credentials will match up locally, but what about the domain credentials? Okay, this is what's important when we're dealing with domain services like DHCP in this case. So what I need to do, log on with domain credentials. Okay, and what we'll see here, okay, is that this server is now authorized. Okay, I'm going to close this because this was open already, and we're going to reopen this just to get a feel for what we're talking about. Okay, and now it's showing is unauthorized. So let's go ahead and reopen this and authorize this now. So we go to authorize. Okay, and all of a sudden it's just we have unauthorized here. So if I refresh this, okay, now it's working. Okay, but we got a whole new mess to think about. We've got this blue exclamation point. What the heck does that mean? Okay, well, this basically means go check your event viewer, but what I noticed this is when we're running out of IP addresses. Okay, and keep in mind what we had set up before. Remember we set up that super scope and we excluded all those IP addresses here? Okay, we had, here's our address pool, our exclusions, 1 through 252 and 254, and then our leases, we've leased out 253, so we have no IP addresses left. Okay, so you see this, if we go check out the event viewer right now, you're going to see that it's going to have a message in there regarding DHCP. Okay, so I'm going to go to the system log here. Okay, and let's go up here, right here, DHCP server, let's check this message out. Okay, belonging to the one is determined is not authorized to start. It has stopped servicing clients. Okay, well this is an older, or actually a newer message. This is when we logged on to that system with a wrong credentials. That's when it ended up being unauthorized. So let's go back here, see if we can't figure out. Here's some more DHCP warning and error messages. Okay, right here, scope 192.168.1.0 is 100% full with only 0 IP addresses remaining. So we're getting a warning letting us know that you've got problems there. You better do something to correct that. Okay, so that's a good thing. It's nice to know that type of information in a network environment. Okay, so what are we going to do with this stuff? Well, what I'd like to do is wipe out this super scope. We really don't need this anymore because we don't have that same situation. So we're going to delete the super scope. Okay, and notice when we deleted the super scope, it still leaves us with our individual scopes here. We have the scope 192.168.1.0 and then our second scope of 192.168.2.0. Okay, so both of these are still active, and they're also actually both working because 192.168.1.0, this here is going to work good on this segment over here. Okay, so just to kind of put in context where we are, we're on server 2 here. Okay, and we're looking at those two scopes. We've got the 192.168.1.0 scope, which of course will help out over here, and we have the 192.168.2.0 scope, which is going to help out over here. Okay, so that's a good thing. We've got those set up already. Now what we'd like to do though, let's change these settings around so we have some IP addresses to give out. So I think what we'll do here is we'll go over here to, we don't need to go to scope options, but we can go to address pool and we'll change the way these exclusions are set up. Okay, we don't need to exclude so many IP addresses. Let's go ahead and delete this exclusion. Okay, and instead, we've already excluded 254. We're going to exclude 200. That's our router's IP address, or actually, did it again, 230. And we'll exclude 100 as well. Now these exclusions really weren't necessary in this example only because we've got such a small network and so few clients that we would never have gotten up to these points here, but I'd like to point them out anyway just so you know what you'd be doing. Okay, these three servers, these three IP addresses, at least 230 and 100 are demonstrated on our network here. Okay, here's 100, here's 230. We're just excluding these so these aren't given out to a DHCP client. Okay, then on scope 2, okay, we do have an address lease out. We're going to delete these leases though. Delete this one while I'm thinking of it. Okay, and we'll take a look at our scope options, our address pool. And here we've got a pool between 1 and 254. We've excluded 200. Okay, if we go back to our picture, remember that it's 200 and 230 we want to exclude. So we'll exclude this IP address as well. And we're pretty much all set here. We've got 2 working scopes. The scope options are configured. And then we have exclusions that are set up to make sure that the server's IP addresses aren't given out. Okay, so let's recap where we're at here then. Coming over here, both scopes are configured. Our router is configured. We can ping back and forth between these machines and over here to server 1 as well. Okay, so we have a fully functional network at this point. Now, what's going to happen if I have XP1 obtain an IP address automatically? Well, we're still at that point. It's still going to be broadcasting out, and that broadcast is going to be stopped by the router, and it's not going to pick up an IP address still at this point. Okay, so what we need to do is move forward and start talking about our DHCP relay agent. Okay, so going back here to our list, we got a good feel for this. We've done the lab setup, scope creation. Now we're going to go over the DHCP relay agent installation and configuration. So we're here on XP1, and we're going to connect over to server 3. Okay, server 3 is located at 192.168.1.230. Okay, so we're here, and we're connecting over to this machine right here. We're going to form a remote desktop connection, and what our goal is here is to set up this DHCP relay agent. Okay, so 1.230. Here we are here. Let's make sure that we log on, and we'll specify the domain credentials to make sure everybody's happy. Okay, let's exit out of this piece. Okay, now we're going to go into routing and remote access. Okay, routing and remote access. And keep in mind, we've already had this enabled because we set up routing on server 3 before. That's what's allowing the traffic to pass back and forth. Okay, and this is also where DHCP relay agents are configured from. Okay, if you click here on General, we're actually going to right-click on General. We have New Routing Protocol. Okay, and it's not really a routing protocol, but it falls underneath here anyway. DHCP relay agent is the option we want to specify. It's this top option here. So we select it. We click OK, and right here, boom, we've got DHCP relay agent added. Okay, now that's not enough. You don't have it configured at this point right now. Nothing is going to work. We need to go here, right-click, go to Properties, and now we have to specify the actual IP address of the DHCP server. Okay, so this relay agent, remember, it's going to pick up those broadcasts. Where is it going to send them? Okay, and this is the address of your DHCP server. So that is 192.168.2.200. That's the IP address of server 2. Okay, looking back at our diagram, we're sitting here. On the relay agent, we're specifying server 2's IP address over here. So I click Add, click OK. We're still not done. Okay, one more critical step is telling the relay agent which interface it's going to be configured on. Okay, going back to our diagram once again, well, there's 2 different network cards here. Which one of these network cards should it be listening on? Okay, should it listen on both? There could be a third network coming in here possibly too. Should it listen on this one? You need to tell it. Okay, and in our case, we don't need to worry. Remember clients over here? If they broadcast out, the DHCP server is going to hear them fine. So there's no issue with putting it over here. This side, however, when these client computers broadcast out, they're going to need to contact this relay agent. Okay, so that's where we're going to configure it. We're going to configure on this side on the 192.168.1.230 interface. So coming back over here, we right-click relay agent, go to new interface, and now we have to select one interface or the other. And we're selecting this one right here. The 192.168.1.0 interface is the one that it's going to be listening on. Okay, we have some configuration options here that you can change if you want to. The defaults are okay, so we're going to leave these as they are and then click OK. Okay, so this is now enabled. Okay, should be set up and working, ready to go. Okay, so now it's time to test this out. Let's see if our DHCP client can actually get through and get an IP address. And we'll point out right now, so far, we have this enabled, request receive 0, reply 0, request discard 0, reply discard 0. Okay, so no statistics at this point right now. So we're coming back over to here XP1. What we're going to do now, we're going to make this machine a DHCP client. It's going to broadcast out. What's supposed to happen, the relay agent hears this cry for help and basically says, hey, you know what? I'm configured to help you out. So it picks up that broadcast and it's going to redirect that request over here to server 2. Okay, let's see if this actually works. Alright, so I'm going to come here, right click My Network Places, go to Properties, and we're just going to change this machine into a DHCP client by clicking Obtain an IP address automatically. Okay, so we click OK, and remember before we were able to do this, it just picked up one of those automatic private IP addresses. Let's see what happens this time. We're going to go to a command prompt. Okay, type in ipconfig, and look what we have here. Okay, it picks up 192.168.1.1, so it's got the proper IP address. That means that, wow, if this is working correctly, we should be able to ping our domain controller. Oops, forgot a number there. Just wondering why that didn't work. Our domain controller, yes, that works. Okay, we should be able to ping our default gateway, 1.230. Okay, that works as well. And we should be able to ping the other side of the network as well, if all is working good. Okay, that's 2.200 is our actual DHCP server. Okay, and that one, we're actually not able to ping for some reason. I wonder why. Okay, we'll take a look at our settings here and we'll see possibly why we're not able to ping that. So when this times out, we're going to type in ipconfig all. Okay, and when we type this out, we see that the DHCP server that we spoke with is 192.168.2.200. Okay, we got the proper DNS server, WIN server. The lease was just obtained. Here's the IP address we picked up. So pretty much all the information that we needed to get from the other machine we picked up. Okay, now the default gateway, when I'm looking at this number here, this is where a mistake is. This default gateway should be 1.230. Okay, so our scope information is incorrect. And what's happened here, because that scope information is incorrect, we're not able to get over the other segment. Okay, so, and this is going to cause us problems too. If I wanted to configure server 2 right now, I'm not able to. If I form a remote desktop connection over there, well, I can't get there. I get over to here and I don't know where to go with it. I'm actually looking and everything's fine over here. I just can't get back over here to server 2. So it seems kind of silly because we were able to get over there to get an IP address, but now that we have the wrong IP address information configured, we're kind of stuck. So what do? Well, we could statically configure it to switch up server 2 and correct that problem. Okay, or we could pause this video and I can change up that scope, and that's what I'm going to do. So just to reiterate, I'm going to pause this video right now. I'm going to change the scope options over here so they're the correct options. Okay, once they're correct, we'll just do a release and renew. We'll do that same test just to make sure that everything goes through okay before we check out statistics over here in server 3. Okay, so we'll be right back up and running. Okay, yep, and that was indeed the problem. Quick change over there. We had that from a previous lab set up. The default gateway was 192.168.1.200 for scope 1 and 192.168.2.200 for scope 2, okay, which is incorrect now with these settings here. Okay, so if we come back over here to the command prompt, we're going to release. Okay, and once this is released, we're just going to renew this once again. Okay, so I hit my up arrow, type in renew. Now we're broadcasting back over the network. We're hitting that DHCP relay agent once again, seeing if it's going to help us out. Okay, and now you can see the default gateway has changed to 1.230. If I ping my DHCP server now, let's see if we can't get through. Okay, 192.168.2.200 is the IP address of server 2. Okay, and now all of a sudden this is working. So we've got a clean network set up at this point right now. So that's a good thing. Okay, let's minimize this. Let's go take a look over here. Okay, on a relay agent. Okay, remember before we really had no statistics, so we're going to shorten these down so we can see these a little bit better here. Okay, and I'm going to just hit F5 and refresh this. Okay, request received 6, replies 4, discarded 2, replies discarded 0. So we see that we're getting some positive statistics. Not all of them work, so it takes a little bit of time to get this through, but the relay agent is set up and it's working as it's supposed to. Okay, so this is a great way to set up and configure a DHCP server across a segmented network like we see here. Now, one thing I do want to show you is, what if, for example, this machine were plugged in over here? Okay, how does it react? Does it work? Okay, so what we're going to do right now, I'm going to unplug this machine. Instead of it being plugged into a hub over here, okay, remember we have a hub right here, and we have a hub right here. Okay, let's see how it reacts if we were to put another machine over here. Okay, so what if we put an XP client over here and we just plug it right in? What IP address is it going to get? Is it going to work correctly? Okay, let's see if we've got that set up. Okay, so to simulate this, this machine is going to be taken offline and it's just going to be plugged in right over here. Okay, so picture XP1 just moving right over here. We're going to release our IP address, renew it, and we'll see if it changes up the information that it gets. So I'm going to stop this momentarily, just long enough to unplug a cable and plug it right back in, and we're going to run this simple test and see what happens. Okay, just plug this cable back in, so right now XP1 is not here, but it's over here. This is XP1. What we're going to do is we're going to run from the command prompt ipconfig /release, and we're going to release our IP address back to the DHCP server. Okay. Now when we renew it, let's see what happens here. Okay, notice what happens because we're plugged into this side of the segment. We pick up IP address information automatically without having to do anything that matches the correct subnet. So now we have 192.168.2.1 and our default gateway is 2.230. Check this out. Okay, and remember, 2 scopes. We didn't specify which scope we wanted these machines to talk to, but automatically, because the request is coming in from this side of the network, this DHCP server is smart enough to know which scope to give it an IP address from. So this is what XP got. So right now it's 230.1. It should be able to ping here, anywhere else in the network. So let's go ahead and test this out. Let's see if we can't ping our domain controller. Let's say at 192.168.1.100 on the opposite segment there. Okay, you can see that we can ping it. So no matter where a client plugs in, it should be getting the proper IP address based upon these settings. Okay, so that's a good thing. Now we're going to connect over here to server 2 before we conclude this video. And what we want to really do, just take a look at some other properties and some things we can do on server 2. So we'll form a remote desktop connection right back over to server 2 at 192.168.2.200. Okay, and we logged on here and we've got this DHCP console opened up from previous. So what we're going to do is just take a look at some of the different options here. If we right click on the server up top, some of these we've looked at already. We can take a look at statistics though if you want to get a feel for uptime, how many addresses have been released, renewed, how many scopes, how many addresses, how many are in use. So just general DHCP statistics here. Right clicking up here again, backing it up. Okay, if you want to back up your DHCP server's database, not a bad idea to do. This will make it much simpler if something ever happens to the DHCP server and you want to restore these settings pretty easily. Now, for the most part, all the IP information is dynamic, so it's not a huge deal if you lost a DHCP server. But, you know, your scope information, your reservations, your leases, your exclusions, all this stuff you may want to pay attention to. Okay, so select the folder where the DHCP server should place the backed up files. You see right here that it's automatically has a backup folder here. Okay, so I just click OK. Okay, and right now it's going to back this up and it's done for me. So if you're making a nightly tape backup, you'd also have this on tape. Otherwise, you'd have to access this backup off of your hard drive. If I want to restore, okay, we come back up here to right-click on the server again, go to Restore, and it's basically the exact same thing. Now we're just going here, backup, okay. Okay, in order for change to take effect, the service must be stopped and restarted. Would you like to do this now? Okay, so we pretty much just restored this. Okay, it's exactly the same. We didn't change anything. Normally you wouldn't do it as we just did it, however, though. Okay, so we'll wait for this to finish up here. It should be any second. And then once this starts, we'll take a look at a couple other options here. Okay, so looking at the server, we can reconcile scopes. Okay, and this tells us right here, this procedure compares scope information in the database with the registry. So to make sure you don't have a corrupt DHCP scope database, you can do this verification, and it tells us right here that the database is consistent. Okay, and if it weren't, it would tell us down below where we have some issues and errors. Okay, so it can be very helpful in troubleshooting. Right-clicking again, we talked about user classes, vendor classes. We talked about these in the concepts video, DHCP concepts video. And that pretty much wraps up what we can do here. If we go to properties, however, so right-clicking still and then going to properties, we have some other statistics and options to take a look at as well. How often do we want to update our DHCP statistics? Okay, we can choose here. By default, we see that it's set on 10 minutes. If we want this to happen more often, we can boost the time up, okay, whatever you prefer. Enable DHCP audit logging. Write server activity to a file daily to monitor system performance and troubleshoot service issues. This is a good idea. You know, it's on by default, so I would imagine you want to leave this on. Doesn't consume a lot of system resources, so it can only help you in my eyes. Show the bootp table folder. It's probably not a big deal unless you're using bootp clients, which we spoke of earlier. Not very likely. You know, these are considered legacy at this point. No Microsoft operating system is going to run this bootp client that it's mentioning. DNS. This is an important tab. You can set up the DHCP server to automatically update authoritative DNS servers with the host and PTR records of DHCP clients. Okay, that's a good thing. If we look here, this says, and this is the default option, by the way, enable DNS dynamic updates according to the settings below. Okay, so when we select this, we're referring to one of these settings. Do you want to dynamically update A and PTR records only if requested by the clients, or do you want to always dynamically update DNS, A, and pointer records? Okay, so the default is usually okay here. Okay, over here you got a couple options that I think is important to point out. Discard A and pointer records when lease is deleted. Okay, if you have this unchecked, what will happen, you can build up A records, host records, okay, and pointer records. Okay, if the lease is just terminated ahead of time, the lease doesn't expire or it's not gracefully ended, well, your A records and PTR records can build up in the DNS database. This will help to keep that database clean, okay, with accurate information. Then our last option here, this is important for legacy systems, okay? For example, clients running Windows NT 4.0 or Windows 98. Dynamically update A and PTR records for DHCP clients that do not request updates. Okay? This is important. When you're using DHCP, it'd be nice if you automatically updated your A and PTR records. Okay? So instead of just putting an entry in there and having to statically change these, anytime you change an IP address, you want the DNS records to be changed accordingly. So this is important. When you check this box, you're basically making the DHCP server do a little bit more work, but it's well worth the extra, burden on the DHCP server. And then lastly, we have our advanced tab here. Okay, and for the most part, I think you can leave this alone. You can, however, change. If you want to put the database in a different location, you can do that. If you want to put the backup in a different location, you can do that. If you want the log file to be in a different location, fine. Okay, all this stuff can be manipulated if you choose to do it. Change server connections bindings. Okay, this might not make sense at first, but if you have multiple network cards, you can bind or unbind DHCP to a particular network card. Okay, for example, you may have a small company, may have 2 network cards. One network card might be connected out to the internet. One network card might be connected internally to your local network. Well, you don't want to have your public internet network card bound to DHCP. So I could uncheck a box right here if it said, internet card and we had a public IP address on there or something. And then our last option, DNS Dynamic Updates Registration Credentials. Okay, assuming that you want to go out there and you want to update the DNS server, and maybe you're not in a domain environment like we are here, we have the ability to provide credentials that will allow us to contact that DNS server and basically say, hey, I'm Joe Blow server here. You know who I am. I know your credentials. I would like to update these DNS records automatically. I've been configured to do so. Here are the credentials I need in order to do that. Okay, so that just gives you the ability to do that. In a domain environment, it's not necessary. Okay, so that pretty much covers our options there. We've talked about the scopes, server options, all this stuff has been covered. So that really wraps up what we're doing with DHCP. Okay, hope you found this informative. We appreciate you watching. If you have any questions. So that wraps up Lab 4 and also finishes out our DHCP and Server 2003 update video. Thank you for choosing Train Signal.